Okay, let's look at our next two types of problems that we need to learn how to do for stoichiometry. And that is the mass to moles. That's our third problem type. And then the fourth type is going to be mass to mass. So what's important here? Your known is going to be given to you in grams or kilograms. It's just going to be in mass. And from there, you're going to have to then put the molar mass into the train tracks, then your mole ratio in order to get to your unknown, the answer for your unknown. So let's go ahead and do this first problem. How many moles of aluminum will be produced from 30.0 kilograms of aluminum 2O3 aluminum oxide in the following reaction? So notice that we have our coefficients here in the reaction, so we can go ahead and say that the reaction is balanced, and we can go ahead and get started with writing our knowns and our unknowns. All right, so let's go ahead and solve this problem. How many moles of aluminum will be produced from 30.0 kilograms of aluminum oxide in the following reaction? So first of all, we need to know what type of problem this is. This is going to be a mass to moles problems. Let's go ahead and write our knowns and our unknowns. So our known is 30.0 kilograms of aluminum oxide. And notice that it's in kilograms. And we need to go ahead and convert that into grams. So that's going to be 30,000 grams. Also, let's go ahead and take this number and put it into scientific notation so that we keep our number of significant figures. So this would be 3.00 times 10 to the, let's see there, 3/4 grams of aluminum oxide. And our unknown, what it is that we're trying to solve for, that is going to be our moles of aluminum. All right, so the first thing that we're going to do is solve for the molar mass of aluminum oxide. So this molecule contains, ionic compound contains aluminum and oxygen. We have 2 ions of aluminum and 3 ions of oxygen. The mass of aluminum from the periodic table is 26.98 and oxygen is 16.00. And when we put that into our calculator, we get 53.96 and 48.00. There we go. We add that up, and you should get 101.96 grams. Oh, here we go. Grams per mole. All right. And I'm going to go ahead and try to get this to scroll down. Just give me a little bit more space. And let's go back to our pen. All right, now we can put down our railroad tracks, and we're going to start with our known, which is 3.00 times 10 to the 4th grams of aluminum oxide. And the next thing we're going to put is the molar mass of aluminum oxide. So this is going to be the 101.96 grams of aluminum oxide at the bottom. And there's in 1 mole of aluminum oxide, we have that 101.96 grams. Don't forget that when you are doing the molar mass in your train tracks, it's always going to be 1 mole. The mass is for 1 mole of that compound. Okay, now let's go ahead and put our mole ratio. So we have, from our balanced reaction, we see that we have 2 moles of aluminum oxide, extend the line there, for every 4 moles of aluminum. All right, so you're going to put all of that into your calculator. Remember, multiply across the top, then multiply across the bottom, and then divide those 2 numbers. All right, so when you do all of that work, you should come up with 588 moles of aluminum. All right. Hopefully that helped and made some sense to you. Let's do one more just to make sure. So let's see here. The problem states the first step in the industrial manufacture of nitric acid is the catalytic oxidation of ammonia. The reaction is run using 824 grams of ammonia and excess oxygen. How many moles of nitrogen monoxide are formed? Now, don't let all of these words in the problem scare you because you don't know what catalytic oxidation is. Just go straight to the important information, okay? Which is our numbers, our grams, what compound that number and unit goes with, and our question, which is going to be moles of nitrogen monoxide. Now, this reaction is not balanced, so it does need to be balanced. And when you do all of that fabulous work, making a reactant and product chart, T-table, you will find that your coefficients should be a 4, 5, 4, and 6. All right, now we can write our knowns. And our known is 824 grams of ammonia. And what we are trying to solve for is the moles of nitrogen monoxide. So once again, let's go ahead and solve for the molar mass of ammonia. Notice that I'm solving for the molar mass for that compound that's given to me in grams. All right, that's really important that you see that connection. So we have 1 atom of nitrogen, 3 atoms of hydrogen. Nitrogen, once again, from the periodic table is 14.01, and hydrogen is 1.01. And we add all that together, and we get 17.04 grams per mole. And let's go ahead and put in our train tracks. So we are going to start off with 824 grams of ammonia. And because we're starting off in grams, the next thing we're going to do is put in our molar mass, because when all else fails, remember to convert to moles, okay? It's so important that you always get your grams into moles, or you take your moles, if you're unknown as in grams, you can take your moles and convert those into grams. But the moles are the important things. The moles are the bridge from one compound in the reaction to another compound in the reaction. So we're going to go ahead and put our 17.04 grams of ammonia at the bottom. And 17.40 grams of ammonia is in 1 mole of ammonia. Now we can do our mole ratio from the reaction, and we see that we have 4 moles of ammonia, and we also have 4 moles of nitrogen monoxide. Now remember, this is a lot like a fraction. So if we have 4 over 4, they cancel each other out. So that in the end, this problem just becomes 824 divided by 17.04. So when you put that into your calculator, you should come up with 48.35 and lots of other numbers. Putting it in proper sig figs, though, we are going to get a final answer of 48.4 moles of nitrogen monoxide. All right, so that is our example problems on how to go from mass to moles. Now, your homework, which will be due Tuesday, the 24th, at 8:30 in the morning, is going to be the problems that you see here. All right, I hope that was helpful. And then the next thing that you will find, you'll find a link for this video in OneNote. You'll also see a link to this video in Moodle. And the next thing you'll find is a video on the 4th type of problems, and also, which is the gram to grams, and also an explanation of today's classwork. I have been getting lots of questions, emails on that, so I'm going to go ahead and give you an explanation as to what you are expected to do. And also, I will tell you about the new due date and time for that video, since there's been so much technical difficulties today. I hope y'all are doing well. See you later.